In this part of the lesson, we're going up a step further again, and we're now going to look at volume units. So now let's look at volume units. Volume is the amount of space that occupied in 3 dimensions. Like, let's say for instance, you are inside of a room, you could figure out how much space is occupied by an object because of its volume, the amount of space it occupies in 3 dimensions. Now, volume is measured in 3 dimensions, so therefore we would have units that correspond to it in cubic. The volume is just simply the area of an object multiplied by how much distance that area seems to have covered. Let's say for instance we have a cube. I should really draw a better cube than that, but let's say for instance we have a cube. We know 1 meter squared is the area on this face of the cube. Just like we had before with the tiles, each having to add up the areas so that we could figure out the total area, the same thing has to be done with the volume. Instead, however, we are going to take the area that is at the front of the object and simply multiply it by the length of the object so that we can figure out how much space it actually occupies. And we will see right away that this occupies 1 cubic meter if the unit here for the length is 1 meter. So we have the length by the width by the height. And let's say for instance we have to figure out the volume of an object. In this case, the 20, 15 by 10, we will have a length of 20 meters by a width of 10 meters and a height of 15 meters. Notice that each one of them will multiply by each other. 20 by 10 is 200. 200 by 15 will be equal to, I think that's 3,000. 200 by 15 will be equal to 30 with 1 2 zeros, 3,000. And we'll have 1 unit of meter, 2 unit of meter, 3 unit of meter, meter cube. Get accustomed to stating units with your values if they have them, because it will help you in the long run to maintain context. Notice that right now we can recognize that if you're given something in the unit of meters, you are looking at a distance. If you are looking at something in the unit of meter squared, you are looking at an area. And if you're looking at something in the unit of meter cubed, you are looking at a volume. So just as before, we will actually be converting it the exact same way. We say meter to cubic meter. I should write that in a different color. Meter to cubic meter. Centimeter to cubic centimeter, millimeter to cubic millimeter, and kilometer to cubic kilometers. Notice the values, as I said, the exact same. We have kilos. Kilo is 10 to the power of 3, which is 1,000. We raise that to the third power, we get 10 to the power of 9. And this now becomes the conversion factor when I am dealing with cubic kilometers, km to the third power. And the same pattern maintains for all of them as you keep going along straight throughout the entire thing. So since we understand what's going on here so far, let's be a little bit quick about the conversion. The conversion, first off, we remove the prefix. So okay, centi, which is 10 to the power of minus 2, since we are dealing with volume now, that is cubic, or in 3 dimensions, we raise that to the third power, we'll get 10 to the power of minus 6. So that's how we get this 10 to the power of minus 2 raised to the third power, so that we can convert this to 1200 by 10 to the minus 6. Then we simply divide by the value that we wish to convert it to. We are converting it to cubic kilometers. Kilo is 10 to the power of 3. Cubic kilometers will be equal to 10 to the power of 9. Notice we have 10 to the power of 9 on the underneath here.